You would have thought that we have more than enough image editing models out there at the moment. But in this video, I once again present you yet another image editing model, EmuEdit. The reason why I decided to cover it on the channel is that it brings something new to the table. Before I go into the details of this model, let me give you a bit of a background why I think this is a bit unique. We all know that image editing is a widely used application, especially with generative AI, that millions engage every day. Popular image editing tools either demand considerable expertise and are time consuming to use or are quite limited. Especially, I am talking about vision language models because they provide only a predefined set of editing operations such as specific filters or something like that. Even if there is a generative AI powered tool, it is limited in a sense. Instruction based image editing attempts to resolve these limitations by enabling users to effortlessly describe their editing goals using natural language instructions. This is where the modern day vision language models are shining. For example, a user can provide a model with an image and instruct it to some prompt that model will follow and edit the image accordingly. Now, there is also a problem with these VLMs. While instruction based image editing models like Instruct, Pix2Pix, and various other are designed to process any given instructions, they often struggle to accurately interpret and execute such instructions. Also, their generalization is quite limited, often falling short on tasks that deviate slightly from those they were trained on. To address these gaps, this new project, EmuEdit, really shines through. This is the first image editing model trained on an extensive and diverse set of tasks, including both image editing and computer vision tasks. And that is why I think this brings something new to the table. EmuEdit provides a substantial improvement in both compliance with the edit instruction and preservation of the visual fidelity of the original image. There are a lot of matrices which are scattered throughout this report and accompanying paper which you can read through, and I will drop the link in video's description. The success of EmuEdit stems from two key contributions. Before I tell you about those contributions, let me show you the examples of this EmuEdit from their model page. So for example, on the left hand side, you can see that the prompt is replace sunglasses to the goblet. There you go. How good is that? And then in the second one, replace a book with a laptop, dress it with a blue hoodie. There you go. And similarly, if you keep looking at these images, make the egg look like a smiling something, crystal version. There you go. So how good is that? And if you very closely look at it, the attention of detail is really awesome. And there are a few more examples. Look at this one. Add a clown hat on the head. Hair are still there. Look at the base of the head. And then, so you can edit the image just with text prompts. And the good thing is that it is quite flexible. And as I said earlier, there are two key contributions to why this is so successful. First, they have trained their model to multitask across 16 distinct image editing tasks. These tasks span region based editing tasks, free form editing tasks, and computer vision tasks, all formulated as generative tasks. Unlike other models, they have developed a distinct data curation pipeline for each task, allowing them to gather a training set that is not only more diverse but also more precise in its examples. They have found out that training a single model on all tasks yields better results than training expert models on each task independently. Secondly, to process this wide array of tasks effectively, they have introduced the concept of learned task embeddings, which are used to steer the generation process towards the correct generative task. Concretely, for each task, they have learned a unique task embedding vector. and integrate into model through cross-attention interactions and by adding it to the timestamp embeddings. They have also demonstrated that learned task embeddings significantly enhance the ability of their model to accurately infer the appropriate edit types from the freeform instructions and execute the correct edit, and that is where it really shines through. So all in all, amazing model in my humble opinion, because richer data improves machine learning results, as we all know, and this proves it yet again. Specifying tasks and generating images that reflect them improved EMU edits data compared to other models out there at the moment, and that is why it is achieving better results. Text to image generators are amazing, all of them, to be honest, and they are really fun to use. So, but the problem is that their outputs are more often than not frustratingly unpredictable. So that is why this innovation with EMU Edit is quite groundbreaking in my humble opinion. Let me now also show you some of the examples and comparison with other models. On your screen, you can see that on the left hand side, the prompt is text and the first image, and we are asking the model to make it play a rainbow colored trumpet. So on the basis of the input image and this prompt, look at the EMU edits output. It has very correctly converted the trumpet into a rainbow colored trumpet. So in the first image there was no trumpet at all, but EMU edit has not only produced a trumpet with all the correct lines and stuff, but also has made it rainbow colored. Instruct Pix2Pix, which is also a quite good model, has not been able to produce a trumpet, rather it has just made the whole image as rainbow colored. Whereas Magic Brush has produced some trumpets where you can see hint of some of the rainbow but nothing else. Similarly, in the next example, the next text is add two unicorns on top of the car. So you see, our model, this EMU edit has done it fine. There are two unicorns there. In the next one, this one, instruct Pix2Pix, there is no unicorn at all. You see a unicorn way in behind the tree there, if you look at my cursor. And in the Magic Brush, there are two unicorns, but they are very tiny and frustratingly small, plus they are not on the top of the car. Similarly, look at again, change the legs to be bionic. So our model has done it, but the rest of the two models have really either deformed the image or have put it in the wrong way. So these are some of the baselines where the other models are struggling to comply with our instructions. So all in all, amazing model in my opinion. I will drop the link to it in video's description. Let me know what do you think. By the way, this is from Meta. If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.